The central meaning of the question, did God design the transistor? The tiny device that changed everything is a metaphorical inquiry into the origins and significance of this revolutionary device. At its core, the transistor operates as an electronic switch or amplifier using minimal power, making it fundamentally different from earlier devices like vacuum tubes. Operating logic involves controlling electrical current through a semiconductor material such as germanium or silicon. This process modulates the flow with a third terminal, enabling amplification and switching functions essential in modern electronics. Early transistors were less efficient, but offered advantages like smaller size, lower power consumption, and higher reliability compared to vacuum tubes. Measurements of early transistor performance showed improvements over time, with advancements driven by better semiconductor technology leading to miniaturization as described by Moore's law. The impact of the transistor is profound, enabling the development of computers, smartphones, and countless other technologies that rely on digital signals processed through these tiny switches. In summary, while not literally designed by a deity, the invention of the transistor was a monumental achievement driven by human ingenuity. Its effects on technology are undeniable, underscoring the power of scientific discovery in shaping our world. The transistor operates as an electronic switch, modulating the flow of electrical current with a third terminal. This simple yet profound mechanism is at the heart of its design and function. The transistor's ability to amplify or switch electronic signals makes it indispensable in almost every modern device. The process begins within semiconductor materials like silicon or germanium. When voltage is applied to the base of the transistor, it allows current to flow between the emitter and collector terminals. This modulation can be controlled by varying the input signal, making the transistor a versatile component in circuits. Experiments and observations have consistently demonstrated the transistor's effectiveness. For example, early experiments with contact transistors showed significant amplification capabilities. The development of bipolar junction transistors and field effect transistors further refined these concepts, each with its own unique characteristics and applications. While the metaphorical question, did God design the transistor, invites a deeper philosophical inquiry into human ingenuity versus divine creation from a purely technical standpoint, it is clear that humans developed this device through complex scientific research and experimentation. The process of creating transistors involves precise measurements and controls over materials at microscopic scales. The tiny device changed everything by enabling the miniaturization of electronic devices, leading to advancements in computing, communication, and consumer electronics. This mechanism begins within semiconductor materials like silicon or germanium, where specific regions are created by doping to control charge carrier concentrations. The emitter part receives an input signal that controls the current between the base and collector terminals, making it a versatile component in electronics. Measurements confirm its efficiency across various applications, from consumer devices to complex computing systems. Observations show that while this design is elegant, its development was driven by systematic research rather than any supernatural intervention. Humans developed the transistor through experimentation and observation, showcasing the power of human ingenuity without attributing it to divine creation. The scale at which transistors operate is striking. They can be made incredibly small, allowing for miniaturization in electronic devices. Boundary cases exist, as there are limits to how small a transistor can be made while maintaining functionality. The current state of the art technology allows for transistors with features measured in nanometers, enabling the powerful and compact devices we use today. This design has enabled monumental advancements in computing, communication, and consumer electronics, driving the miniature computers in our smartphones and laptops. While the metaphorical question, "Did God design the transistor?" invites deeper philosophical inquiry from a purely technical standpoint, it was the result of human innovation and observation. This simple mechanism allows for precise control over the on and off states. However, competing explanations exist around its origins, adding layers to our understanding of this device's development. For instance, while some might argue that God designed it, a metaphorical stance suggesting an almost divine intervention, others point to the meticulous work of human scientists such as William Shockley, John Bardeen, and Walter Brattain. These inventors spent countless hours in laboratories, experimenting with semiconductor materials like germanium and silicon. The boundaries here are clear. While the transistor's function is based on well-defined physical principles, its creation involved a series of uncertain steps and potential alternatives. For example, early attempts with different materials could have led to entirely different devices or none at all. The exact sequence of events leading to the first successful point-contact transistor remains open to interpretation. In 1947, Shockley, Bardeen, and Brattain demonstrated their invention, marking a turning point in electronics, but leaving room for debate about the precise nature of its design process. Competing explanations vary from divine intervention to the ingenuity of human inventors working within scientific constraints. The exact process by which the first transistor was created remains a subject of discussion, with no clear consensus on whether it was a divine design or simply an outcome of human ingenuity. The transistor's operation is based on its ability to act as an electronic switch, modulating electrical current flow through a third terminal known as the base. This occurs within semiconductor materials like silicon and germanium, where input signals at the base control the modulation process. From a purely technical perspective, the device represents a significant achievement in miniaturization and power efficiency. However, the deeper philosophical inquiry into whether it was designed by a deity introduces uncertainty. The development of the transistor by scientists such as William Shockley, John Bardeen, and Walter Brattain at Bell Labs in 1947 is clear, but questions about its origins and motivations remain open to interpretation. While the exact measurements and observations that led to the invention are well documented, understanding the precise conditions under which this breakthrough occurred remains a matter of speculation. The transistor's impact on modern electronics cannot be overstated, as it enabled the development of countless technologies from computers to smartphones. A less examined present implication is how this tiny device has influenced the way we think about innovation and creativity. In its simplest form, a transistor operates by modulating the flow of electrical current using a third terminal. This mechanism allows for an electronic switch that can be turned on or off with precision. The process begins within semiconductor materials like silicon, where impurities are added to create regions of high and low conductivity. When an input signal is applied, it controls whether the current flows through one side or another. While the transistor itself is a purely technical component, its development represents a monumental achievement driven by human ingenuity. By 2023, miniaturization had reached unprecedented levels, with transistors shrinking to sizes measured in nanometers. This ongoing process has enabled ever more powerful and compact devices, from advanced microprocessors to the sensors in our smartphones. The metaphorical question, "Did God design the transistor?" suggests a deeper philosophical inquiry into the nature of innovation itself. In reality, humans have developed this tiny device through rigorous experimentation and observation. How did engineers and scientists manage to transform a simple theoretical concept into something that could literally change everything? The role of theoretical physics in Did God Design the Transistor? Quantum mechanics played a pivotal role in explaining how electrons could be controlled within a semiconductor material. This control is essential for modulating electrical current, which is achieved through a third terminal known as the base. The process begins within the emitter region, where an input signal influences electron flow. These principles were first elucidated by theoretical physicists who explored the behavior of electrons at quantum scales. Experiments and observations in the laboratory confirmed that electrons could indeed be manipulated with precision, leading to the development of transistors. This foundational work laid the groundwork for the transistor's operation as a versatile electronic switch. The tiny device changed everything because it enabled miniaturization on an unprecedented scale. Without the theoretical underpinnings from quantum mechanics, engineers might have struggled to understand and harness these microscopic phenomena. Quantum mechanics played a pivotal role in explaining how electrons could be controlled within the transistor. The device operates as an electronic switch, modulating the flow of electrical current with a third terminal, the gate. This mechanism begins within the semiconductor material, where the emitter and collector terminals facilitate electron movement. Experiments and measurements confirmed that by applying a small voltage to the gate, the flow of electrons between the emitter and collector could be controlled, enabling the transistor to function as an on-off switch. The theoretical framework provided by quantum mechanics was essential for understanding these phenomena at a microscopic level. It allowed scientists to predict and explain how tiny variations in electrical potential could control electron movement within the semiconductor material, making the transistor's operation possible. Without this knowledge, engineers might have struggled to understand and harness these microscopic behaviors. Compared with earlier technologies like vacuum tubes, which were previously used for amplification, transistors offered significant advantages. Vacuum tubes required high voltages and produced heat, limiting their efficiency and reliability. The transistor, however, was much smaller, more reliable, and could switch on and off much faster than vacuum tubes. The development of transistors marked a turning point in the evolution of electronic devices. While humans developed this tiny device, it did so without the aid of any divine intervention. Its success was driven by the precise understanding of quantum mechanical principles and relentless experimentation. In comparison to vacuum tubes, which rely on thermionic emission, where electrons are emitted from a heated filament, the transistor's operation is more efficient and reliable. Vacuum tubes were bulky, consumed significant power, and had limited lifespans due to their heating elements. The transistor's size and efficiency made it ideal for amplification and switching applications. The impact of the transistor on modern technology cannot be overstated. It enabled miniaturization in electronics, paving the way for advancements like smartphones. This tiny device changed everything by making electronic devices smaller, more powerful, and less energy intensive. Transistors are now integral to a wide array of technologies, from computers to portable audio players. In summary, while the transistor's transformative impact is undeniable, its development was grounded in scientific principles rather than divine design. Its success stems from meticulous research and innovation, making it a remarkable achievement that continues to shape our technological landscape today.